Okay, this is a video on Unit 2, Day 5 notes. I'm going to do a couple examples from the notes on solving quadratics by factoring. I'm going to do number 10, 12, and 14. So let's start with number 10. And I'm doing this on a separate sheet so I have more space. The notes, I know there's not a lot of space. You're welcome to do this along in your notes if you want, but I'm just doing it on a separate piece of paper for space. All right, so here's my problem for number 10. So we know when I am doing this, solving quadratics by factoring, the first thing I need to make sure is that it equals 0. So I'm good, it equals 0. Second, I always check for a GCF. No GCF in this problem. All right, now I'm going to kind of think through what kind of quadratic is this, how can I factor it, what methods can I use. There's more than one method for this. I'm going to do it one way. There's another option I'll talk about after, but I'm just going to say, oh look, my A is 1. This is my easy kind of factoring, right? This coefficient is 1. That means I could actually draw these parentheses in and put my x's in, and I'm just looking for the two numbers that go here. And those two numbers are the two numbers that multiply to be A times C and add up to be B. So A times C, right? A is the coefficient of x squared, B is the coefficient of x, and C is the constant. So this is my A, this is my B, this is my C. And that negative goes with it. So A times C is 1 times 9, and B is negative 6. So I'm looking for two numbers that multiply to be 9 and add up to be negative 6. Not a lot of factors of 9, right? 1 and 9, or 3 and 3. So if I want it to be positive, but add up to a negative, we're looking at negative 3 and negative 3. And I just pop those numbers in here, because this is the easy kind of factoring. You also could have factored this by saying that that was a perfect square, that was a perfect square, and that was 2 times the square root. That was another option, but we're going to keep going this way. So now I set my factors equal to 0. They are the same, right? X minus 3, x minus 3. Those are the same two factors, so I don't need to write it twice. I'm going to get the same answer for both. If I add 3 to both sides here, plus 3, I get x equals 3. And this is a double root. It's a double root because you can see I have double factors there. They're the same factor. What this means, when you graph it, it means that the vertex was on the x-axis. So it only touches the x-axis in one spot. So if I graph x squared minus 6x plus 9, and I hit graph, it touches in one spot. That one spot is 3. And remember, you always want to check these. We're not solving by graphing, but we're just checking using our calculator to make sure we did it right. So that's my one spot. It only touches in one spot, so I have one answer, and it is a double row. So double root for this one. X is 3. And we checked it, and we're good. Number 12, we have 3n squared plus 4 equals 13n. All right, our first step is make sure it equals 0. This problem does not equal 0 right now. So I'm going to move this 13n to the left. And the way I move from right or left is by adding or subtracting. If this is positive, to move it, I'm going to do minus 13n. Now, I purposely tried not to write the 13n under either of these terms because it's not like terms. It's not like terms with 3n squared. It's not like terms with 4. So you can't combine it, so you're just going to write it in standard form, meaning my biggest exponent, then I work my way down. All right, now it equals 0. Now I'm going to look for a GCF. Nope, no GCF. Now I'm going to check and see what my A equals. On this one, my A is 3. So this is my harder kind of factoring. To remind myself I'm doing it, I'm going to draw these two little lines here to remind myself that my goal is to split this middle term into 2 terms, because I'm trying to turn this into 4 terms. So I'm going to do A times C and B, but this time instead of those actually just going into these parentheses, I'm splitting up my term. So A times C, 3 times 4, and B. So two numbers that multiply to be 12 and add up to be negative 13. So we have negative 12 and negative 1. So that's negative 12n minus 1n. That's what these two numbers are doing. They're splitting up that negative 13n. And then I need to make sure I write the rest of the problem, the plus 4, and of course it starts with 3n squared. Now I have 4 terms, now I can group. So I'm going to group these two together and look for a GCF. My GCF is 3n. When I divide each term by 3n, I get n minus 4. Here, my GCF is negative 1. Remember that if my first term is negative, my GCF is always negative. My first term is negative, so I know my GCF has to be negative, and in this case, it's negative 1. That means all of these signs get flipped. And at this step, before I go any farther, I'm going to check and make sure that what I have inside my parentheses is exactly the same. Same letters, same numbers, same signs, exactly the same. So I'm good to go. That's one binomial, and the second one is your leftovers, or your GCFs, the 3n minus 1. So now I've factored it. So now I set each factor equal to 0 because I'm not just trying to factor, I'm trying to solve it. So this one is plus 4, and I get n equals 4. This is a two-step. First I'm going to add. That gives me 3n equals 1, then divide by 3. So always add or subtract first when solving equations, then you can divide. And again, you're going to take the couple seconds it's going to take you to put the problem in and make sure you got the right answer. When you put the problem in, if it did not equal 0, you can't put this in, right? I don't have a button that says 13n equals. It needs to be down here, equals 0. And the reason I can put this in for y equals is because we're looking for x-intercepts or where y is 0. So we're looking for the points that make y 0. So this right here, my y is 0. It can go in 3, and I always use x if it's a different variable. So 3x squared minus 13x plus 4, hit graph, and it should go through 4 and 1/3. And again, this is a quick check. I can easily see it goes through 4. I don't have a tick mark at 1/3, but I can see that it's in about the right spot. So I'm good. We're just doing a quick check. We're not solving by graphing. All right, last problem. Let's take a look at number 14. So I have x squared minus 8x plus 12 equals 0. So first we make sure it equals 0, and it does. Then we look for a GCF. Nope, no GCF. So now we can try factoring. So I'm looking here, my a is 1. This is my easy kind of factoring. This is the kind of factoring, I can already set it up like this. I'm just looking for the two numbers, and those two numbers are the two numbers that multiply to be AC and add up to be B. A times C is 1 times 12, which is 12, and B is negative 8. So two numbers that multiply together to be 12 and add up to be negative 8, that would be negative 6 and negative 2. So minus 6, minus 2, and the factoring part is done. Now you set each factor equal to 0 because we're not just factoring, we are solving. We're looking for where it crosses the x-axis. Plus 6 gives me x equals 6. Plus 2 gives me x equals 2. That means it crosses at 6 and 2. We're going to do a quick check and make sure that that's actually the right answer. X squared minus 8x plus 12, hit graph, and make sure it crosses at 2 and 6. Yep, so we are good.